Ever get that feeling, that little shiver down your spine when you see a hurricane swirling on the news?
Oh, definitely.
It's like this weird mix of awe and, whoa, that's powerful all at once. Well, today we are diving deep, no pun intended, into the science behind these incredible storms.
Yeah, it's interesting. We toss around the word hurricane a lot.
We do.
But what really makes it different, what sets it apart from just a big old storm, is that incredible power source they've got. Imagine like a giant vacuum cleaner, but instead of dust, it's sucking air upwards.
Oh, wow. So,
That's the low pressure at hurricane's heart. And that, my friend, is what drives those insane winds.
and those winds,
Yeah.
speaking of, can be fierce.
Yeah.
I mean, we hear about the Saffir-Simpson scale, right? But then you see footage of a Category 5,
Oh, yeah.
and suddenly it gets real.
Oh, for sure, and for good reason. Category 5s, those are the heavy hitters. We're talking winds 157 miles per hour or more. Ripping roofs right off, trees down, the works.
Nature's demolition crew for sure, especially compared to a Category 1, which, while still dangerous, feels almost, well, polite by comparison.
Right, a Category 1 is no walk in the park, don't get me wrong. But that jump to a 5, it's exponential in terms of sheer destructive power.
Okay, so let's break down this hurricane recipe, so to speak. You mentioned a power source earlier, warm ocean water, right? Is that our first ingredient?
Absolutely. Warm ocean water, that's the main course for a hurricane. They crave that heat energy, and they need water temperatures of at least 80 degrees Fahrenheit. That's about 26.5 Celsius for our metric listeners. Can't even get started without it.
So no hot tub, no hurricane party.
Exactly. And it's not just about having the warmth, it's about the air above that water. That air needs to be absolutely loaded with moisture. Like, think about the humidity on a sticky summer day, but like, times 1,000.
So that humid air, thick with all that moisture it's sucking up from the ocean,
Yeah.
that rises and creates those massive storm clouds, right?
Bingo. As that moist air rises, it cools down and all that moisture condenses and boom, you get those towering thunderclouds. That's classic hurricane.
Okay, so we've got the warm water, the humid air, like a sauna for a storm. What else?
But just like a good sauna, hurricanes need the right environment. One thing that's super important is low wind shear. Now, I know that might sound like jargon.
It kind of does, yeah.
So think of it this way. Imagine trying to build a house of cards, but you're in a wind tunnel. That's high wind shear. It rips the storm apart before it can even get going. Low wind shear, on the other hand, means nice, calm, consistent winds, allowing the hurricane to keep its shape and grow.
Ah, so it's like the opposite of that chaotic wind tunnel. It's like a calm space for the hurricane to kind of do its thing.
Exactly. And every great storm, every good party needs a starting point, right?
Yeah.
Something to kick things off.
Gotta have that initial spark.
Exactly. For a hurricane, that spark is a pre-existing weather disturbance, something like a low-pressure area, maybe a tropical wave. It's like a little seed that, with the right conditions, can explode into something enormous.
Okay, so we've got our warm water, our humid air, our calm winds. What else is on the hurricane grocery list?
Well, we can't forget about the Earth itself getting in on the action.
Right. It's not just the atmosphere partying here. It's a whole planet affair.
Exactly. That's where the Coriolis effect comes in.
Yes, the spin cycle.
Exactly. Imagine, try drawing a straight line on a basketball, but the basketball's spinning.
Okay, I can visualize that.
That line's going to come out looking curved, right?
Into it, yeah.
That's essentially the Coriolis effect in action. Because the Earth is constantly rotating, anything moving a long distance across its surface, like the air masses forming our hurricane, gets deflected. And that creates that spin.
Which explains why hurricanes don't form right on the equator. They got to be a bit further out to really feel that spin, right?
Exactly. They need a bit of a runway.
Okay, I'm getting a picture of this. So we've got our ingredients mixed, the spin cycle's going.
Yeah.
How does this swirling concoction actually become a full-blown hurricane? It's not like someone flips a switch, right?
No switch flipping here.
Mm-hmm.
Hurricanes, they go through stages like a development process, each with its own little quirks and warning signs.
Like the awkward teenage years of a weather system.
Exactly. It all starts with what we call a tropical disturbance. It's basically just a cluster of thunderstorms hanging out over the ocean, not very organized, kind of just figuring things out. But if those conditions are just right...
Things get a bit more interesting. That disturbance, it can level up, become a tropical depression.
Which is where we start to see some rotation, a closed circulation taking shape. Still relatively calm winds at this point, but that telltale spin is starting to emerge.
It's finding its groove. And then, like a dancer who's finally nailed their routine, if that tropical depression keeps it up, it graduates. It becomes a tropical storm.
And with that graduation comes a name. That's right. Once a storm hits wind speeds between 39 and 73 miles per hour, it officially gets a name from the big list meteorologists keep. They put a lot of thought into those names, by the way.
Oh, I bet. I mean, you don't want to give a storm a name that's too silly if it's about to cause serious damage. But it's like the storm's finally old enough for a driver's license. Things are getting real.
Right. And we start to see that iconic spiral shape forming, those bands of clouds and thunderstorms wrapping around the center. A dead giveaway. But
Okay.
it's still not quite a hurricane, not
Yeah.
until.
Not until those wind speeds hit a roaring 74 miles per hour or higher. That's when our awkward little storm, it's all grown up, it's a full-blown hurricane.
That's when the real fun begins.
And that is where we are going to pick up after a quick break. All right, so we cooked up this swirling monster of a storm, officially a hurricane.
Yeah.
But what's going on inside that spin cycle? It can't all be chaos, right?
You'd be surprised. Right at the heart of all that fury, there's actually an area of incredible calm, like an oasis in the middle of the storm.
You mean the eye? Yeah, I've seen pictures. It's weirdly peaceful looking, especially with everything around it.
It really is something else. Imagine you're in the thick of it, howling winds, torrential rain, the full force of nature bearing down. And then you look up, and there's blue sky. That's the eye. A zone of descending air, so the winds are light, skies are often clear. Surreal experience.
Wow. Talk about a contrast, though. Surrounded, of course, by the most intense part of the hurricane, that infamous eye wall. Definitely not a place you want to get stuck sightseeing.
No kidding. If the eye is the calm before the storm, the eye wall is the main event, no holds barred. We're talking highest wind speeds, heaviest rainfall, just raw power. It's the engine room of the whole hurricane.
And then spiraling out from that central maelstrom, we've got those massive arms, those rain bands, right?
Exactly, those rain bands. They can extend for hundreds of miles outwards, carrying all that heavy rain, strong winds, even spawning tornadoes, and you're nowhere near the center. It's a good reminder that a hurricane's reach, it's much wider than just the eye wall. You got to respect the whole system.
Okay, so we've built our hurricane, stepped inside its surprisingly calm eye, figuratively, of course. But they're not static things, are they? They can power up, weaken, even just kind of fizzle out. What makes a hurricane gain or lose steam, so to speak?
Well, remember that warm water we talked about, the hurricane's fuel? Imagine this. Hurricane's moving along, hits a patch of even warmer water. It's like hitting the gas pedal.
Oh, so it can actually strengthen as it goes.
Absolutely. It's called rapid intensification, and it can be a bit unnerving, to be honest. Might think you have a day to prepare, then bam, Category 1 turns into a Category 4 overnight. Makes forecasting a real nail-biter sometimes.
Wow, that's intense. So warm water's like pouring fuel on the fire. What about things that can weaken a hurricane, though? What's its kryptonite?
Two big ones. Dry air and that wind shear we talked about. Remember how crucial that moist air is? How it acts like the hurricane's fuel source? Dry air, that disrupts the whole process. Starves the storm, basically.
And wind shear. That's like that disruptive force messing with its structure, right? Like trying to build that house of cards in a wind tunnel, like you were saying earlier.
Exactly. High wind shear can rip a hurricane apart, messes with its circulation, weakens the whole thing. It's one of the reasons why when a hurricane moves over land, it tends to lose steam. Land disrupts the airflow, cuts off the warm water supply.
Right, it's like hitting the brakes and cutting the engine all at once. But even a weakening hurricane making landfall, that's still incredibly dangerous, right? I mean, it's still a hurricane.
Absolutely. That's something people really need to keep in mind. The danger doesn't just vanish because it's moved over land.
Yeah.
You've still got those dangerous winds, the potential for torrential rainfall, and of course, the storm surge.
Speaking of, storm surge is one of the scariest things about hurricanes, isn't it? That wall of water just crashing inland.
It's a major threat, often causes more damage than the wind itself, believe it or not. See, as those powerful hurricane winds push towards the shore, they pile up the water, causing a huge rise in sea level. Add to that the torrential rainfall that usually comes with hurricanes.
And you've got a recipe for some serious flooding.
Exactly. Rivers overflowing, dams breaching, entire neighborhoods underwater. The impact on people's lives, the environment, the infrastructure, it's devastating. And the recovery takes years, sometimes decades.
It really drives home the power of nature, doesn't it? And how important it is to be prepared. But I got to ask, how do meteorologists even begin to predict these storms? And what can we do to stay safe?
That's the million-dollar question, isn't it? The science of hurricane prediction has come a long way, but it's a constant challenge to stay ahead of these forces of nature, trying to predict where a hurricane will go, how strong it'll get. It's like trying to predict what a toddler's going to do next sometimes. They've got a mind of their own.
I can only imagine. So much unpredictability.
Yeah.
But, that's a fantastic point for us to pick up on in our next episode. We've talked about the what of hurricanes. Now we need to dive into the how of predicting them.
Absolutely. It's a whole other world of science and technology, and it's evolving all the time.
Well, listeners, sounds like we've got our work cut out for us. But for now, we're going to take a short break. And when we come back, we'll unravel the mysteries of hurricane prediction. Stay tuned. You know, it's amazing, really. It's like Mother Nature's got this whole other level of cooking show going on with these hurricanes. All those ingredients, the timing, it's wild.
It really is fascinating, isn't it? And understanding that process, how it goes from a little disturbance to a full-blown hurricane, that's key to predicting how they'll behave, even if it's just a few hours warning.
Which I imagine is crucial when you're trying to get the word out to people, give them time to prepare.
Absolutely. The more we know about those early stages, the better we can figure out where a hurricane might go, how strong it might get, and that can save lives.
No doubt about it. But even with the best predictions, seeing the aftermath of a hurricane, it's heartbreaking.
It really is. The pictures, the stories, it's just a glimpse of the devastation. Homes, businesses, entire communities,
Yeah.
just gone. And the emotional toll, the long road back, it's something you can't truly grasp until you've been through it.
A powerful reminder that as amazing as these storms are from a scientific point of view, there's a human cost too.
Always. And with climate change likely leading to even more intense hurricanes down the line, understanding these storms, how to prepare for them, how to lessen their impact, well, it's more important than ever.
Knowledge is power, right? The
Yeah.
more we know, the better off we'll be.
Exactly. It's all about learning, adapting, and respecting the incredible power of nature.
Well said. And on that note, we've reached the end of our hurricane deep dive. We've gone from the calm eye of a storm to the chaos of the eye wall, unraveled the science behind their formation, and talked about their potential for both awe and, let's face it, destruction.
It's been quite a journey.
It has. And for all of you listening, we hope you're walking away with a little more knowledge, a little more understanding, and a whole lot of respect for the power of hurricanes.
And for the meteorologists who dedicate their lives to tracking these storms and keeping us informed.
Absolutely. Until next time, stay curious, stay safe, and we'll catch you on the flip side of our next deep dive.